All right, welcome to this next video. In this next video, we're going to be dealing with differentiation of exponential and logarithmic functions. And we can see that the logarithmic functions are given in these two. So we've got the derivative of e to the x, which is just e to the x. And if I've got a function like the ln of x, it is the same as saying the derivative of 1 over x. But I also want to dive deep into another one. So if I've got the ln of, I've got another function here, let's say ax plus b, its derivative will also be given by, you'll have to get the function as it is at the bottom, and then you'll get the derivative of that particular function at the top. So therefore, this derivative will then, in this case, just become a. So that's how we then derive these logarithmic functions. So another title is to say, if I've got the ln of f of x, the solution to that will just be the derivative of f of x over what f of x is. And that's how we do the derivatives of logarithmic functions. So let us dive deep into our question. So here you can clearly see we'll use the chain rule because we've got e to a particular function. So therefore the dy dx of that, this derivative becomes e to the 2x minus 1, because the derivative of e to the 2x is that. Then we derive the inner function, which is 2, so we can simplify that to 2e to the 2x minus 1. Let's deal with the next one here. The derivative of that will just be e to the x3 minus 3x squared minus 5x minus 2. And then we'll multiply that by the derivative of the whole function, which in this case will be 3x squared minus 6x minus 5. And that is the derivative. Let's look at this next question here. Here we'll use the product rule because we've got two functions. And remember what the product rule says we need to do. The product rule does say that we need to go derive the first function. We have 3x squared, keep the second, plus we keep the first function as it was, and then we derive the second. So the derivative of e to the x is just e to the x, and then we just have to derive the inner function. So let's simplify this for ourselves. This then becomes minus x to the 3 e to the minus x. So it becomes quite nice and easy to do. So the next one over here, we've got a quotient. So we'll then have to use our quotient rule in order for us to simplify this. So let's see how we get the dy dx of this. So the derivative, the dy dx says derive the top function. So this is e to the cos x. Now we derive what cos x is, which is minus sine of x. And then we now subtract. And then when we subtract on this one, we keep, I forgot the e there. So therefore, remember we have to keep e to the x at the bottom. Now we then have to minus this and then go the derivative, or we have to fix the top, e to the cos x, and then we have to find the derivative of the bottom, which is just e to the x. And then all of this is going to be over e to the x squared. So this is how we then find that particular derivative. So please double check on that, make sure everything is good. Now, the one point I was trying to emphasize now is if we've got derivatives of natural logarithms. So according to this, as I've specified there on the side, the derivative of this will be, firstly, it'll be 1 over, we keep the function as it is, and then we take the derivative of that, which is 2. So that's how we would then do derivatives of logarithms. So what I'll do, I'll just jump right to g, and then I'll come back to f over here. So the derivative of this dy dx, as you've guessed it, we'll firstly rewrite the function as it is in the denominator, plus 4x. And then here at the top, we'll write the derivative of this function. So the derivative ends up being 9x squared minus 4x plus 4. And that's the derivative for that. And let's do this last one here. We'll use the product rule for this one. And in using the product rule, this becomes the derivative of g becomes, you take the derivative of the first function, keep the second, plus you keep the second and take the derivative of this. So the derivative will be 6x over 6. And then we'll try to simplify this in our next line. So this becomes 2x, the ln of 6x, plus the 6's cancel out and the x's cancel out. So this just becomes over x. I hope this video has made sense in helping us try to summarize the derivatives of these exponential and logarithmic functions. I hope this has made sense, and I shall see you in the next video.